Today, we're pulling back the curtain on the unseen conductor that makes everything on your computer work, the operating system.
I mean, really think about it. You're multitasking, right? You're juggling a dozen things at once, and your computer just keeps up. It feels like magic, but it's not magic. It's actually some incredibly clever management happening just under the hood. And the one in charge of it all is the operating system, or OS. The best way to think about it is like the master conductor of an orchestra. It's managing all the hardware, all the software, and making sure every single piece plays its part at exactly the right time. So let's see how this conductor tackles its first really big challenge.
Okay, so the first major job for our conductor is managing the star of the show, the computer's brain, what we call the CPU, or processor. With so many different programs all wanting to perform, who gets the spotlight?
Well, in computer speak, any program that's currently running is called a process. So your email client? That's a process. Your music player is another process. Even that little notification that pops up for a second is a process. And just like musicians in our orchestra, they all want a solo. They all want to use the CPU.
And that brings us to this really crucial job called process scheduling. This is basically the OS deciding which process gets to use the CPU and for exactly how long. The whole goal here is to be fair, but also super efficient, so your computer feels snappy and responsive and nothing just grinds to a halt.
So, how does the OS manage this lineup? Let's look at this little queue of processes here. That burst time you see is just how much processing time each one needs. The email client needs 4 milliseconds, the music player needs 3, and so on. Now, how should our conductor decide the order?
Well, the most straightforward way is just first come, first served. It's like a line at the bank. P1 gets the CPU until it's totally done. Then P2 gets its turn. But here's the problem. Look at P3, that tiny little notification. It only needs 1 millisecond, but it's stuck waiting behind 2 much longer tasks. That's what makes a system feel slow and sluggish.
But thankfully, there's a much smarter way to do this, and it's called round robin. Instead of letting one process hog the CPU until it's done, the OS gives each one a tiny slice of CPU time, let's say 2 milliseconds, and then it just cycles to the next one, and the next, and the next. This makes sure that short, important tasks, like our notification, get a chance to run almost immediately. And that, right there, is what makes a system feel fast and responsive to you, the user.
Okay, so our conductor can handle who performs and when, but it also has to manage the stage itself, the computer's memory. See, every single running process needs a place to exist in the main memory, which you probably know as RAM. So memory management is the OS's job of handing out this space. It has to make sure every musician has enough room to perform and, this is really important, that they don't start bumping into each other and causing chaos. But this creates a pretty big problem. As you open and close different programs, all of different sizes, the memory starts to get broken up into these small, scattered, empty holes. This is called external fragmentation. You might have enough total free space for a new program, but none of the individual empty spots are big enough to actually fit it. Now, one way to fix this is with something called compaction. The OS literally hits pause on everything, shuffles all the active programs to one end of the memory, and smushes them together to create one big, usable block of free space. As you can probably guess, this is incredibly slow. It brings the whole performance to a screeching halt.
So to avoid that messy, slow process, modern systems use a much more elegant solution. It's called paging. Here's how it works. The OS breaks every program into small, equal-sized chunks called pages. Then it divides the physical RAM into matching slots called frames. Now, a program's pages can be slotted into any available frames, even if they aren't right next to each other. This simple but brilliant idea completely gets rid of the problem of wasted holes in memory.
And the final trick up the OS's sleeve is something called virtual memory. The OS can actually use a section of your hard drive and pretend it's an extension of RAM. This is what allows you to run more programs than you technically have physical memory for, basically making the stage feel almost infinitely large. Of course, an orchestra for a huge blockbuster movie is totally different from a small jazz quartet. And in the same way, operating systems are specialized for different kinds of performances. For example, a batch OS is all about efficiency. It's designed to run massive jobs, like a company's payroll, overnight without anyone having to touch it. Then you have a time-sharing OS, like you'd find on a university server, which is built to let hundreds of users all share one powerful computer at the same time. And then there's a real-time OS. This is for situations where timing is everything. Think air traffic control or a robot surgeon,
where even a tiny millisecond-long delay could be an absolute disaster.
So, after seeing how our conductor juggles every single process and manages this constantly changing stage, we can really start to appreciate just how important it is.
You know, this quote from our source material really just nails it. The operating system isn't just another piece of software. It is the executive manager that makes everything else even possible. It's that unseen conductor turning a chaotic mess of parts into a perfect symphony of whatever you're doing.
And that kind of leaves us with one last thing to think about. From our smartphones to cloud servers to the Internet of Things, our digital world is just exploding in complexity. The demands we're putting on our operating systems are bigger than they have ever been. So the next time you seamlessly switch between apps, just take a second to appreciate the conductor and ask yourself, what is it going to need to conduct next?